Hi guys. Okay, welcome back to the session of Java Think class. Our Think class about object-oriented programming, right? Here we are going to discuss something about Java inheritance, session number 4. Okay, so let's begin. As I've already told you, we are just going to the way of interpretation or way of teaching is just like question answer session. Okay, just we will deal more about the questions and its respective answers, right? So Java inheritance, like the first question that we ask is like how inheritance occurs. Okay, it occurs when the class is derived from the another superclass. So there is some superclass, yeah, and there is also a class. Okay, so for example, this class is something that is similar to the superclass that is already existing. Okay, so the new class you want to derive is somehow related with the superclass that is already existing. So in this scenario you can see something about the inheritance occurs here. So inheritance occurs the new class inherits some properties from superclass. So this is the idea. Okay, so the derived class contains all the members of the class it inherits plus any members it defines explicitly. So the idea is it means is like something not only the properties that it inherits from the superclass. So the new class that you generate can also add new members, okay, explicitly. Then also it's not only this, like it can add the members, but the all the properties that it inherits can be overridden. Okay, so it can explicitly it can just use the method on its own way. Okay, whatever way does it like to use it. Okay, you just like to override it. Okay, the existing method that it has inherited from the superclass, providing its own implementation. Okay, so the keyword that is used in inheritance is extends, because we use the extends keyword for the subclass to extend the properties from the superclass, right? So this is the idea that occurs here. So why inheritance? The big question, another big question is like something, the new class, we want to make it merely different from the already existing class. Okay, so something you want to make a new class. Okay, and if you check it out, like you will see that it's merely different from the already existing class. So so what is the trick to reduce, okay, the repetition of the code? Because if you are going to make a new class, then then if you do not use the inheritance, then the repetition of the code can occur. So how to reduce this kind of repetition of the code is like we use inheritance. Okay, this helps us to use the repetition of the code, because just by using the inheritance we can automatically inherit so many information or the properties already existing in the superclass. Then we can use it so that there is no repetition of the code, plus we can add the methods, okay, that we want. Okay, so it also helps us to do localization of the code. Localization means something fixing something. Okay, so localization means something like whatever you do something in a superclass is repeated. Okay, it's inherited automatically to the subclasses, that the new subclasses that you make. So whatever you do, either you fix the bug, it's automatically inherited to the subclass. Either you add the functionality, okay, this is automatically inherited to the subclasses that inherits this kind of superclass. so automatically everything is done. So there is some kind of localization of the code. So whatever is done is already existing, already automatically it's updated. So what are the visibility scopes, okay, for the method and the attributes present in the superclass? So visibility, like what kind of visibility is there, like what is the view, okay, like view in the sense like for example the superclass having all kind of properties. So which properties are viewed, are able to be viewed, or which properties are not able to be viewed, or which properties are protected, private, public. So this kind of is you can check it out, like if the property is a public, then it is easily accessible by the subclass, whereas if the property is private, okay, then it is accessible only by the superclass. So this is something that is only accessed by the superclass, so it is private, okay. So whatever it is, if it is protected, then they are accessible within the class and is subclass, so it's accessible by like almost everyone, right? So how many kinds of reference are present? Two kinds of references are present here. That is a this, okay, and a super. For example, if this reference is present, then this is something that is referring to the current object, whereas if there is a super, then this is referring to the parent class. So this is some keyword that acts as something like a reference which is used to refer to the either to a current object, okay. So whenever you are trying to use a current object in a current class, then you use this as a keyword to do the reference, okay. Whereas if you are trying to call the parent class in the subclass, then you have to use the super keyword to call the parent class in the subclass. Yeah, right now the next question is like how constructor is managed in child class in case of inheritance. So as you guys all know, is what is constructor? The constructor is something that helps us to define the class, define the objects, okay. So it helps to initialize the objects. So what if, so two situation can occur. The situation one is like if the superclass do not have any kind of constructor, like do not have a constructor, then what occurs is like we automatically, the Java compiler inserts a default class with no parameter in the parent class, okay. So having no constructor means there exists a default constructor without parameters, okay. In this case, like if a child class inherits, okay, the extends a superclass, then having the default constructor, okay. So this okay, what occurs is like the execution of the constructor proceeds in like there is some kind of execution of the constructor. What happens is by default it is also automatically inserted, okay, in the subclass, okay. And this kind of execution of constructor proceeds in a top-down approach, okay, in inheritance hierarchy. So in this way, when a method of a child class is executed, then the superclass is completely initialized already. So what about this case 2? Okay, case 2 is the situation when the superclass consists of something like custom constructors. Okay, so custom constructors are those constructors having parameters, okay. So having this kind of parameters, what we can do, what really occurs in the subclass is something like we have to explicitly declare the subclass, okay, these constructors, okay. If having the custom constructors, we have to explicitly declare these constructors by using a super method, okay, and all the parameters must be present, okay. So all the parameters that are declared in the superclass constructors must be present in the child class constructor with the super method, okay, and the method should be passed, I mean the parameters must be passed from here. So in the case 2, having the custom constructors, we have to use the super method, okay, to initialize the constructor. Okay, now what are the features of the class object? Okay, this is a concept about object class, in which what we know is object class is a superclass of all the classes that we create. Okay, object class is something like a superclass. It's above all the other classes that we create. So it is something that whenever we create a new class, it automatically inherits or extends the object class. So that means it is the methods that the object class provides, like toString, okay, like the equal. So these are implemented. These common methods are all overridden, or they are all the useful. These methods are very useful to other classes, and they are used by other subclasses that is generated, okay, or created. So what is this toString? This toString methods return something like a string, okay, that is identified by the object, whereas this equal method just try to test the equality between the two objects, like is this object equal to another object, so something like this, okay. It just try to test the equality, and it returns the boolean value, right? And another point to be noted is like something system.out, that print, okay. So this is a point that is noted, is because whenever you call this kind of method, if you pass the object parameter, then it just print out, okay. And this is same as doing this, like system.out, the print out with object that is calling to the method that is toString. So the toString method is already incorporated in the object. So like using any of this method is similar, okay. They both are going to print out the object, okay. So these are some basic features of object class, and there are more are there, but you can just go out to the Java documentation about object class and get to know more about Java object class. Okay, now casting. Okay, casting, how it is done, okay, and how casting is done in inheritance. So like casting occurs, like, right, as I've already told you, casting is something like type conversion, okay. You cast something and you convert the type, okay. This can occur in any kind of form, like you just try to convert, okay. The conversion occurs in the reference value, the variable, okay. So we have two kind of, most especially we have two kind of casting, that is upper cast, especially in case of inheritance, okay. The casting in case of inheritance is divided into two special parts. First is upper cast, okay, in which what we do is we assign more specific type, subtypes, to more general type, super types. So subtypes is assigned to super type, right? So that also means that whenever a subtype, anytime subtype can be assigned to a super type, then go back to the super type. So this is like something going back to the origin. Like, so for example, a subclass is created which extends superclass. So the subclass can also have its own methods, okay. So this subclass, whenever it wants, can go back to the superclass, okay, with its own original methods, okay, that it has what the superclass has, by just using a simple technique, that is casting, and that is done by uppercast. And the good thing is, like, uppercast is always type safe. Okay, so easily uppercast, we can easily use the uppercast without any kind of errors, right? So each class is the subclass of the object. So as the feature, okay, as I explained the feature of the object class, the another most important feature about the object class is also that the subclass of object, okay, all the classes are the subclass of object, right? So we can easily upcast any instance to object type, because all the class is a extends superclass, superclass object class, okay, right? So easily we can do the upcast in the case of object. Cast on the reference type only affects the reference, while in contrary, a primitive type cast involves a value conversion. What's the meaning? The meaning is, whenever we do the casting of reference, okay, so doing casting in the reference just affects the reference values, okay, just affects the reference, okay. But in contrary, primitive type cast involves value conversion. So the value is converted in case of primitive types. If you do the conversion in primitive types, so such like primitive integer, primitive character, primitive float, or something like this, the value is converted, okay. We have to convert totally the value. Like if you cast the integer to a float, okay, then there is some kind of value conversion going around. Whereas if you are doing the conversion of the reference type, then there is no value conversion, only the reference is converted, okay. So that only reference changes to a new type that you want to convert, right? So this occurs. Now there is the second case, is the downcast. As I already told you, there is upcast in which subclass can go back to the superclass, whereas in the downclass, superclass cannot go back to the subclass, okay, but in certain situations. Okay, let's discuss more about that. So in downcast, what we have already told is the superclass can be assigned to more like specific type, that is subtype, okay. So already here is declared that downcasts are not safe by default. So that means the idea is, like, super subclass having some extra methods, okay. If in case the subclass have some extra method that is different from the superclass having its own method, okay, then it is clearly not possible for for a superclass to come back to the subclass, right? Because the superclass cannot implement the method that is in the subclass. So the idea is this is clearly by default is not possible, okay. So whenever this kind of error occurs, we handle this error by throwing the cast class exception. And in the another question, we'll just deal about how to do the down class in a safe way, okay. So yeah, already I have told you how to handle the down class in the safe way is we use the operator that is the instance of, okay. The idea behind using the instance of operator is like this is something, a check method, okay. This is a check procedure in which the instance of, in which the reference instance of a class, okay. So this kind of method, what it does is it returns the true value if the reference is possible to cast to this class, okay. Reference is an instance of this class. So if this method returns true, then we can easily cast, okay, we can easily perform downcast but whereas if this method returns false, then we cannot do the downcast. So this is something like a checking method to perform the downcast very safely, right? So what are the abstract classes then? Yeah, this is something a new topic. So what are abstract classes? These are the classes which are used to define common behavior for many child classes. Common behavior. So what are common behavior? As I have told you, some common behavior are the behaviors that can be common to many classes, right? So many subclasses can have the same common behavior. So all these common behavior can be specified by using a class that is abstract class, okay? And these classes are not instantiated, so variables are not initialized, okay? Instantiated, and methods has no body, okay? So the idea is if you make a abstract method, then the method do not have any kind of body, okay? It's just like the declaration, okay? Whereas if you just like here, okay, where the abstract class seems to be something like this, okay? And all this method, the idea behind having a abstract class is something like this is implemented later on by the child classes, okay? This can be implemented or overridden by some child classes. Okay, now let's go back to the Java interface. So having the prior idea, okay, pre-idea about the abstract class, so isn't it like, don't you think that there is something like which is possible, which helps us to which acts as an interface between so many classes, like as a common interface in which the abstract methods are implemented by so many other common child classes having this common method. There is a common method, the collection of common method, and this collection of common method is the interface, okay, which is implemented by so many child classes, okay, and is a special type of class, okay, where attributes are implicitly static, or as I have already told you. So this is common to every child classes. So attributes are static and final, methods are implicitly abstract, okay, that means no body is not there, so we cannot instantiate the class, no new objects is there. So and the key point, the point to be noted is like there is no new objects can be created in a interface. Object is never created in an interface, okay, this is the point to be noted, and it is just used to define the reference. So only the reference values, it is just used to define the reference values, right? Only the reference are just defined here, okay, which is used by multiple other subclasses. So what are the rules of the interface then? So what is the master rule of using the interface? The master rule is interface can extend another interface but cannot extend a class, okay? Just this is a master rule, you have to understand this, okay, before using the interface. This can be a handy rule, okay? Interface can extend multiple interface, and similarly for the classes, the rules are class can extend only one class, whereas a class can implement multiple interfaces, okay? So these are just the point to be noted, which helps you later on. And strongly suggested, okay, the point that is strongly suggested is always try to use the interface, okay, which is much more error free, okay, because abstraction class can generate some kind of abstract methods, and this can be create some kind of error later on. So always try to use interface. instead of using the abstract method in the class, okay, which is much more handy. So how can we create a new interface? So creating a new interface is very easy, and we just have to make a use a keyword interface with the name of the interface. That is, right now in the example you can see I am making a comparable interface, okay, and this interface consists of the abstract method, okay, and this is the idea. So how do we implement this interface in the class? Is also very simple, and you just have to use the keyword, that is implements, yeah, and any class that implements the interface is given in this example. So the public class, the name of the class college, implements this interface, like the interface that we have created here, like comparable interface. This is implemented here. We use the keyword implements, and all the abstract method inside the interface that is created, whenever it implements this in particular interface, this particular abstract method inside can be overridden here in the abstract method, wherever you implement the interface, okay. So overall, this was the summary of all the abstract information. Like, this is the abstract of all the information that is common to all the students. So, and this was all about Java inheritance and something more about the interface, okay, and many more such things like casting and so many things. So this much is for this part of session 4. So we will continue more about session 5 later on. Till then, just in the session 5 we might be doing much more about Java collection framework. Okay, so this much for session 4. That's it.